Hello, Will. We're still missing you. Eden, hope you're doing a good job at your volleyball. Otherwise, don't bother coming back if there's no medal. Oh, aquatics. Oh, okay. Don't bother coming back if you don't have a picture of a dolphin. Mac? Well, just get better, my friend. And we all had muffins today. You missed out. Sorry about that. All right. So, question 11. This is of exercise, I don't really know what. 6H. Dan filled us in on that, so that's nice. Okay, so we've got 6H. Oh, I just closed the video from before. Never mind. Why have I done? I was wondering why I've got to. All right, so here we go, peeps. And this is, hopefully checking your understanding of the situation of planes and lines. So, does the line passing through this point, so how I do it, because, there's a lot of things going on in my head. Some of them good, some of them not so good. Right, 0.3, 4 minus 1. So does the line, blah, blah, which is normal to that plane, this is a plane, intersect any of the axis coordinates? So before I can find out if it intersects any of the axis coordinates, don't I need the equation of the line? So then, it's just going back, and I go, okay, well, what do I need to find the equation of a line? No, the normal vector I need for the plane, right? So to find the equation of a plane, right, I need a point on the plane and I need its normal vector. But what they're saying here is what I'm wanting is a line that is perpendicular, right? It's normal or it's perpendicular to that plane. In other words, the direction vector of this line or this line will be the normal vector of the plane. Does that make sense? So the direction vector here of the line, which is normal to the plane, will be 1, 4, minus 1. Agreed? So therefore, the equation of the line, if I'm going parametric, 3 plus t, y equals 4 plus 4t, and z equals minus 1 take 1t. So any questions thus far? Because I heard a grrr from Ethan. I seriously heard We okay? All right, so then we can go on to the next bit. We've got the equation of the line. Well, how do I find out if it intersects any of the coordinate axes? Well, from old stuff that we did, to find your x-intercept, we would have to make y equals 0. That was when we had 2D. So when we've got 3D, to find your x-intercept, y and z have to be 0. So if we take y first, what's the only value for t there? That 4 plus 4t would equal 0. T has to be -1. So then we pop it into z, and we go, I better go y. We go z minus 1 take minus 1. Oh, huzzah! That equals 0. So when t equals minus 1, y will be 0, z will be 0, but what will x be? 3 take 2, yep. 3 take 2, 3 take 1, which is 2. Therefore, it's going to cut the x-axis at 2, 0, 0. Now, Bobalicious said that's the answer, which is telling us that there would not be any intercepts at any of the other axes. But we didn't know that before checking. So what do we expect when we then go to solve for our y-intercept? X has to equal 0, z has to equal 0. So we take our x value and we go, okay, 3 plus t equals 0, therefore t equals minus 3. And then when I sub it into z, I get minus 1 take minus 3, which is 2, which is not equal to 0. So you can see that that is not going to be an intercept for the y-axis. And then we check the z-intercept, and we'd expect to see the same thing because we only saw a solution for x-intercept. Does that make sense? Yeah. but you do have to check all three. Hey kids, so we're blaming Ethan. Oops, we're blaming Ethan today. He's the one. We're saying that 12 just messed with our heads. We talked about 11 and we've just got a little bit stuck on 13. So let's have a look at 13. Show that lines da-da-da-da and da-da-da are coplanar. Now, what Hayden and Moses were saying is that for them to be coplanar, when it says they're not skew, it means then if they're either then going to be parallel, coincident, or they intersect, right? So if we've got our plane and we've got our two lines, so let's call this one here and it's going whoosh. And if we've got our next line here, if it's going to be parallel, what would happen? How would we know that two lines are parallel? Same. They'll have the same direction vector, right? If it is not parallel, if they are on top of one another, oops, they would also have the same direction vector, yeah? To prove that they're parallel, you have to prove, your x, one point does not lie on the other one. So this is back to that G1 or 2 that we were doing, the same thing over and over again, show that they're skew, show they're parallel, whatever. So the first thing we have to do is go, well, can we rule out that they're parallel? And we do that by finding their direction vectors. And you go, well, that's all groovy because the direction vector of line 1 is going to be 1, 2, 1, 2, 1. All right, so the direction vector, don't be sorry, that's fine, is what they are divided by. Okay, and then your direction vector for the second one, and this is where you go, ugh, it's a little bit nasty because yes, we go, it's over 1, but this one, we can't just say it's over 1 because you got that 2 out the front. So that one is actually a half because what you're technically doing is you're timesing a half at the top and you're making, that would then be Z plus or whatever, and you times by half, divide by half, and then we're all good. So if I times by half, I'll get my 1Z. But then I have to divide by half because what I do to the top, I have to do the bottom. So I've actually got the direction vector is 1, 1, 1/2. And so we go, well, they're clearly not the same. Therefore, they're not parallel and they're not coincident. So we have to prove that they actually intersect to show that they are coplanar. Now, if they don't intersect, that would mean they're skew and therefore they're not coplanar. And then we're in strife. Okay, so that's when we go back to that other thing that we used to do. What was that exercise? Oh, I keep doing that. And this is when, right, each little skill on its own, we go, oh, that's quite nice. But now when they keep going in one into the other, that's when you have to have really nice notes and maybe go through and highlight. This is where we're finding where lines intersect. This is where we're finding where you'll see it when it's that yucky one with the T's and but it was quite nice. Going. Did I pass it already? No, here it comes. This one. Remember we did this? But it already seems like it was ages ago. But anyway, so we come over here and we make our x's equate the x's, equate the y's, equates the what have you. All right? So we have to put that in a nicer form. Okay, so all we're doing is, for me, I don't know about you, but I find it easier when everything's in parametric form. So I've just gone back and popped the line 1, right? So my point would be 1. So that's why it's 1 plus t, and then 2 plus the 2t, and then you reverse the sign, minus 3 plus 1t. That's for the pink. The blue, same sort of thing. You just had to be careful with this one. That was the real pain in the butt. Okay, so I just said, that's a 2 actually. Sorry about that, Eden and Mac and Will, right? So we didn't want that 2 there, so to get rid of that, we could times by half, or what you do at the top, you do the bottom. And so if I actually did times that all out, I get my half times 2 is the z, but a half times 5 gives me 5 over 2. So that means my parametric will be minus 5 over 2 plus a half t. Correct? So what do we do now? We make our x's equal each other. I mean, quite frankly, if we don't find that these intersect, the rest of the question is over, because then we don't find the equation of the plane. So we're going to go equate your x's. So 1 plus t equals minus 1. Ooh. No. No. What have I done wrong? Oh, oops, I was in the zone with the parametric and we got to this and I'm going, hang on, stop. But this is what's going to happen, right? And you go, what have I done? Because you cannot go, oh yeah, it's just 1. Because if you were solving this, the t's would cancel and I've got 1 equals minus 1 and that doesn't make sense. And you go, hang on, these are two different equations of lines, and so I was very naughty, I should have had different variables. Bad, Ange. So if we go back, and I guess I wouldn't have done that if I had been following my example nicely. All right, you can see you've got the 2 variables. All right, so fix that. I'd like to say I did that deliberately, but it was a unknown error. I do miss your singing. Oh no. It's up to you what you want to use. Sometimes my S's look like 5s. Whatever you want to do. What shall we go with? I mean, I should have gone lambda here, really. Oops, here, but okay, lambda. It's out of whack again. Your 1. Oh. Not having a good day today. Ah, yeah, we'll get there. Thanks, Bob. The reason you had, oh, sorry guys, they had muffins today. But I had a little bit of a headache and I thought, oh, it'll go away. But I'll get Panadol just in case. So I went to get Panadol and then I remembered that I owed my home group scone/muffins if they had no red crosses at all. And then it just steamrolled from there. But anyway. Play, maybe. Yes. Good save. Yep. So we're going to now equate. And hopefully things will be better this time. So you're looking at the x's and we go 1 plus t equals minus 1 plus lambda. So you'll get an expression with t and lambda. Then you're going to equate your y values. Yes? And then you'll solve for lambda and t. Check that it works for z. Have you finished the question? No, because we want to find the equation of the plane. Now, what 2 things do you need to find the equation of a plane? Normal vector and a point. So the point that you find here where they intersect, you could go with that. Oh, actually, you could go with any point. Couldn't you? You could pick 1, 2, minus 3. Anyway, how do you get your normal vector of the plane? So you've got these 2 up here, mate. So we've got our 2 lines which we now say are intersecting. Right, we've got that one there. We've got this one here that's intersecting. And we want to find a vector that is parallel to both of these lines. How do we get a vector that is parallel to 2 other vectors? Cross product of these 2. And that will give you your normal vector for your plane. Correct? Thank you. And yes, I mean, you could use that point of intersection if it's nice. Otherwise, technically, you should be able to use any point from the lines. Okay, so Bella and Aman were meant to do the explaining for this one, but time beat us all, so let's have a look. So we've got A lies on the plane. So we've got a plane, the plane. We've got A and it lies on there. So how can we find K? Right, that's your X value, that's your Y value, this is your Z value, and we have that the equation of the plane is X plus 2Y take 2Z equals 8. So I hope you're all yelling out, sub. Okay, so you're going to sub X is 1, 2 times 2 is 4, take 2K equals 8, and then hopefully you will find K. So that's quite pleasant. Now we want the coordinates of B, and we go, all right, what's going on with B? So AB is normal to the plane. So in other words, we've got, let's change tactic, let's go this one. So normal to the plane, it's just another fancy word for perpendicular. So it's perpendicular to the plane, and notice I didn't just stop at A, because who says B is up here? So it could be 6 units this way, it could be 6 units that way. My legs went this way and my arms went that way. Okay, so how are we meant to know? And we go through, like, I'll be honest with you, when I'm doing this first off, I'm going, oh, well, what is B? If I call it X, Y, Z, okay, and I suss my distance formula. So remember, our distance formula is x1 take x2 all squared plus y1 take y2 all squared plus z1 take z2 all squared. All right, we try that, we go, oh, this is going so well. Distance is 6. And then what's the point? Well, point is A, so I'd have x take 1 all squared plus y take 2 all squared plus z take, and we should have stopped by now, and I think you end up with k is minus 3 on 2, so they're squared, and to get rid of the square root we would square. But what's our problem? We have got not 1, not 2, but 3 unknowns and only one piece of information. So that is no good, and I have to come up with something else. All right? Distance is involved, definitely, so we are going to have to use this formula, but I cannot have so many unknowns. And my clue to you is think about the equation of a line, and can you express the form of any point that lies in this line, right? We don't know what B is, so instead of calling it X, Y, Z, we're going to use the equation of that line to say what X is. So we have our direction. To find the equation of a line, we need the direction vector. Now the direction vector of this line comes from our plane, because we've got this is 1, 2, minus 2. So direction vector is 1, 2, minus 2. And we have the point, which is 1, 2, right, your A point, and minus 3 on 2. So therefore, any point that lies on this plane would be 1 plus direction vector, so 1t. And then 2 plus 2t, and then, sorry, it's getting a bit messy with my writing, but minus 3 over 2 take 2t. So that's any point, and we can say, well, this would be point B. So if I now pop this into my distance formula, and some of you might be groaning, going, oh my God, this is going to be disgusting. So your x, which is 1 plus t, take away your point. But look at that, take away 1, they're going to cancel, so squared. And then y, which is 2 plus 2t, take away your y value, which is 2. So once again, they're going to cancel. And lo and behold, minus 3 over 2 plus, oops, no, take 2t. Take 3t, so plus 3 over 2 squared. So once again, they cancel. So it ends up being not so bad. Okay, and now we've got 36 equals t squared, 2t squared, so just be careful, 2t squared, we're squaring the whole thing, so that becomes 4t squared, minus 4t squared is another, so minus 2t squared is another 4t squared, so we end up with 36 equals 9t squared. Too many year 12s ask me, what do I get rid of first? The squared or the times 9? Grr. We should know this. If I start with t, it's being squared, then times 9. So times 9 is the last thing that happens. So it's the first thing I have to undo. So we divide, equals t squared. So I've got 4 equals t squared. So t equals plus or minus 2. And therefore, when you sub it back in, that's why you will get your 2 values, or your 2 different points for b. Huzzah. So try and keep on going with that. Also go and have a look at GeoGebra. But basically, yep, try and catch up. Cheers.